Hello, and I hope you're all having a good day. Today we're going to be talking about practice problem 4 from section 8.5, which concerns partial fractions. First, let's take a look at the starting fraction for this problem. That is 3x minus 37 over x squared minus 3x minus 4. We can't really do anything, at least with partial fractions at the moment, so let's simplify the denominator. That gets us 3x minus 37 over x plus 1 times x minus 4. This is something we can work with, and so we're going to take this new fraction and we're going to split it up based on how partial fractions are formatted, which gives us a over x plus 1 plus b over x minus 4. Notice that we're kind of just ignoring the numerator, and we're taking the two terms of the denominator and just adding them together with a and b, which are no more than placeholders that we'll be solving for later in order to finish our partial fraction. Now, it sounds weird, but we're actually going to want to recombine the two terms back together, which gets us the following: 8a times x minus 4 plus b times x plus 1 over x squared minus 3x minus 4. This lets us set it equal back to our original term, which is the backpedaling we need to do to help us solve for a and b. That ends up looking something like this, and you'll notice that both sides of the equation are over x squared minus 3x minus 4, which just allows us to cancel them out, leaving us with just the numerator terms. 3x minus 37 equals a times x minus 4 plus b times x plus 1. Now, as it is right now, we have three unknowns, which is nightmarish to try to solve for just brute force, but we can be a bit clever and see if we can plug in terms for x, which allows us to get one unknown. Fortunately, with partial fractions, we are well able to do that. So if we take this equation and we find these x's, which allow this scenario, you'll find that x equals 4, makes it so a goes to 0, 4 minus 4 is 0, times a goes to 0, and that only leaves the b term because the x plus 1 will go to 5, so we get minus 25 equals 5b, which ends up with b equals negative 5. And then in the same fashion, we can plug in x equals negative 1, which then makes it so the b term goes to 0, and then we can solve for a with negative 40 equals negative 5a, which gets us a equals 8. Now the last step is to plug these a and b values back into the partial fractions that we had, which ends up as 8 over x plus 1 minus 5 over x minus 4. And now we have our fully solved partial fraction.